Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chemical bonding. Okay, we have started with what is chemical bonding, how many kinds of bondings are there, what is ionic bond, what is covalent bond we have seen in the earlier session. Now here in this session we are going to say about sigma bond and pi bond. Okay, before going to say about these two bondings, first let us see what is meant by valence electrons and valence of atoms. Okay, electrons which are already paired in valence shell can enter into bond formation if they can be unpaired first and shifted to vacant orbitals of the slightly higher energy of the slightly higher energy or the same energy level. This state is called excited state. Generally, the single electrons present in the valence shell orbitals, that we can say half-filled atomic orbitals, they will participate in the bond formation and hence those single electrons will be paired. Or in the other way, the electrons present in the paired form in the valence shell, they also can participate in the bond formation when certain amount of energy is supplied to that atom. Then these paired electrons will become unpaired and one of those two electrons will jump into higher orbitals of the same main shell. Then they become half-filled atomic orbitals or they become single electrons. These can participate in the bond formation. When these paired electrons become unpaired and those electrons shift into vacant orbitals with the slight energy in the main shell, in the same main shell, that state is called excited state. Okay, this happens when certain amount of energy is supplied to the atom, and even this happens before the bond formation. So certain atoms before bond formation, they come into excited state. Excited state means electrons present in the normal condition, they jump to higher orbitals in the same energy level. Okay, and they become single electrons and then they participate in the bond formation. That state is called excited state. This point explains the trivalency of boron, tetravalency of carbon, and pentavalency of phosphorus. In the similar way, hexavalency of sulfur. Okay, these all are explained by this excited state concept. Actually, if you say carbon, the atomic number of carbon is 6. And if we write the configuration of carbon, what do we get? 1s2, isn't it? 2s2, and next 2p2 means 2px1, 2py1, isn't it? This is a general configuration of carbon. Here 2p z orbital also will be there, but it is completely vacant. No electrons are present in it. Now how many single electrons are there for carbon? Only two electrons are there. So it should form actually only two bonds. But what's happening here in the case of carbon means while it is going to participate in the bond formation, it absorbs certain amount of energy initially, and these paired electrons in the valence shell, they split, and one electron from here it jumps to 2p z orbital. Now it becomes 2pz1. Totally the electron configuration will be for carbon in the excited state will be 1s2, 2s1, 2px1, 2py1 and 2pz1. Totally there are 4 unpaired electrons. These 4 unpaired electrons will participate in the bond formation with 4 covalent bonds, and hence carbon is getting tetravalency. Okay, so this is state where one electrons jumped by unpairing this pair of electrons into higher orbitals of the same shell is called excited state. So in the excited state, carbon is having 4 unpaired electrons or 4 half-filled orbitals. These will participate in the bond formation. Before that, only 2 electrons are there. So the tetravalency of carbon is explained in this way. Similarly, boron also, even phosphorus and hexavalency of sulfur, and even heptavalency means the 7 valencies of fluorine or chlorine are explained by this excited state concept. Okay, see here the excited state are being explained with the diagrammatically. If we see boron, it has only 3 valence electrons. Out of these three, two are paired. Only one single electron is present. So actually you should form only single bond. But before bond formation, by absorbing certain amount of energy, these two electrons become unpaired and one electron jumps to empty 2py orbital. Now it becomes 2s1, 2px1, 2py1. In that way, it is getting 3 unpaired electrons or 3 half-filled orbitals. These will participate in the bond formation and form boron forms 3 covalent bonds. So the same we have explained now in the carbon case also. Actually, it has two unpaired electrons only, but after excitation means after absorbing energy, one electron from 2s jumps into vacant 2p orbital. So it will get 4 unpaired electrons. These will participate in the 4 covalent bonds formation. Okay. In the similar way, phosphorus it has three unpaired electrons and 2 paired electrons. But in the excited state, one electron from 3s it jumps to 3d subshell, 3d vacant orbital. Now it gets 5 unpaired electrons. Because of the presence of 5 unpaired electrons, phosphorus can form 5 covalent bonds. So its pentavalency of phosphorus is explained in this way. Okay. So here one point is important. Dumbbell-shaped p orbitals will form stronger bond as compared to spherically symmetrical s orbitals. Okay, dumbbell-shaped p orbitals can overlap each other very strongly than in the case of s orbitals overlapping. So the chemical bond formed with p orbitals will be stronger than s orbitals. Based on the difference in the overlappings between the atomic orbitals, covalent bonds are classified into two types. They are sigma bond and pi bond. So based upon the type of overlapping existing in the formation of covalent bond, these covalent bonds are classified into two types. They are sigma bond and covalent bond. First let us see about sigma bond. The covalent bond formed between two atoms by the end-to-end or axial overlap of half-filled atomic orbitals along their axis is called sigma bond. Okay, the covalent bond formed by the overlapping of atomic orbitals end-to-end or on their axis is called sigma bond. A sigma bond is the first bond formed between any two atoms. So, in the covalent bond formation, when the two atoms approach each other, when atomic orbitals overlapping, first they form a sigma bond by overlapping their atomic orbitals on their axis of nuclei. Okay, sigma bond is stronger because the extent of overlapping between the electron clouds is maximum. The electron cloud of S bond is symmetrical about the line joining the nuclei of two atoms. Yes, sigma bond is a strong bond because this is formed between the two atoms for the first time when they two approach each other. So there the overlapping of atomic orbitals will be to a much extent. As overlapping increases, is stronger, bond formed also will be much stronger. Okay. So now in the formation of sigma bond, the overlappings of atomic orbitals will be different kinds. Those will let us see here the types of overlapping of atomic orbitals in the formation of sigma bond. First let us see SS overlapping means s orbital overlapping. Let us understand, try to understand this SS overlapping by taking an example, that is formation of hydrogen molecule, H2 molecule. We know each hydrogen atom has one electron in its 1s orbital, which is spherical in shape, isn't it? Now, 1s orbital of Both the hydrogen atoms approach each other closely when they reach a point of maximum attraction by the two nuclei. They overlap and form a sigma bond. Suppose this is a s orbital of one hydrogen atom with one single electron, and this is the s orbital of another hydrogen with one single electron. When these two hydrogen atoms approach each other, when they reach a point of maximum attraction between the two nuclei, then these two s orbitals overlap each other and hence they share this pair of electrons, and thus they form a covalent bond which is called a sigma bond. And this sigma bond is formed between the two hydrogen atoms by the overlapping of s and s orbitals, and hence it is called ss sigma bond. Okay, hydrogen molecule has ss overlapping and ss sigma bond between the two hydrogen atoms. So the bond has two electrons which have opposite spins. The probability of finding these electrons is maximum in the region between the two nuclei of the molecular axis. The electron density of the bond is distributed symmetrically about the molecular axis. So this is the way the bonding is happening in the H2 molecule by SS overlapping. See here, first hydrogen is having single electron. It is also having single electron with the clockwise spin. When these two hydrogen atoms approach each other, the s orbital of one hydrogen atom merges with s orbital of another hydrogen atom. That means they come one into another. That is called overlapping. So it is happening here, SS overlapping. Immediately these two single electrons will be paired with opposite spins. One will be with the clockwise spin, the other with the anti-clockwise spin. So the probability of finding these two electrons will be maximum in between these two hydrogen atoms on their axis of nuclei. And hence a sigma bond is formed between these two. Okay, this is called SS overlapping. Next, let us say another kind of overlapping, that is sp overlapping. S orbital, p orbital overlapping in the formation of a covalent bond. Let us understand this by taking an example, hydrogen fluoride molecule. We know fluorine has a valence shell configuration as 2s2, 2px2, 2py2, 2pz1, because its atomic number is 9 and its configuration is 2, 7. Means in the valence shell it is having totally 7 valence electrons. So out of these 7 valence electrons, it has only one electron in the single state, isn't it? Remaining all electrons are paired. Only there is one unpaired electron. It has one singly occupied orbital, that is 2pz orbital, isn't it? This 2pz orbital of fluorine overlaps with 1s orbital of hydrogen. Here hydrogen has one electron in its 1s orbital. So 1s orbital is singly occupied. This 2pz orbital and 1s orbital of hydrogen, when these two approach each other, they overlap each other and form a sigma bond. This sigma bond formed between the hydrogen and fluorine is called sp sigma bond. Okay, this overlapping is called sp overlapping. So here, this is a s orbital of hydrogen with a single electron. This is 2pz orbital of fluorine which is having single electron. When these two approach each other, s orbital of hydrogen overlaps with 2pz orbital of fluorine, and hence they share the pair of electrons mutually between them. And hence a covalent bond is formed which is called sigma bond or sp overlapping. Okay, this is happening there. Initially, hydrogen has one single electron. Fluorine also is having one single electron in its 2pz orbital with clockwise spins. When these two approach each other to a certain distance, where the force of attraction is maximum between these two nuclei, there s orbital of fluorine hydrogen overlaps with the 2pz orbital of fluorine, and hence they share the pair of electrons, and thus sigma bond is formed between them. Okay. Some other molecules, just like the hydrogen fluoride molecule, other examples for the molecules having sp overlapping are water, H2O. In the H2O also, between oxygen and hydrogen, there exists a covalent bond which is formed by the sp overlapping of atomic orbitals. S orbital of hydrogen and p orbital of oxygen, they overlap each other and results a covalent bond. In the same way, in the ammonia molecule also, hydrogen s orbital, p orbital of nitrogen overlap and form one covalent bond between each nitrogen and hydrogen. Okay, they are the molecules which are having sp overlapping. Okay, sp overlapping means the covalent bond formed by the overlapping of s orbital of one atom and p orbital of another atom is called sp overlapping, and thus the sigma bond formed is called sp sigma bond. Okay, next let us another type of overlapping, that is pp overlapping. So let us understand this by taking an example, that is a formation of fluorine molecule, F2 molecule. You know, this is illustrated by the formation of fluorine molecule. The electronic configuration of fluorine will be 2 comma 7 to say simply, because atomic number of fluorine is 9 and its configuration is 1s2, 2s2, 2px2, 2py2, 2pz1. Means fluorine has only one unpaired electron in its 2pz orbital. When so it is having one single occupied orbital, that is 2pz orbital. When two fluorine atoms approach each other, the p orbitals of these two fluorine atoms overlap each other, okay, and forms a sigma bond like this. So this is one fluorine atom which is having one unpaired electron in it in its 2pz orbital. This is another fluorine atom having in the same way one single electron in its 2pz orbital. When these two fluorine atoms approach each other, they form a single bond which we call as sigma bond. This overlapping is called PP overlapping. If you observe, this is SP overlapping, PP overlapping, and SS overlapping. These all are happening on their axis of nuclei on this line, which is joining their two nuclei. That's why these all are called sigma bonds. The, the covalent bond formed by the overlapping of atomic orbitals on end to end means this overlapping occurs on their axis of nuclei. Thus, the bond formed is called sigma bond. Some other examples for the molecules which are having PP overlapping are Cl2, O2, etc. In these molecules also, this PP overlapping is occurring in the formation of covalent bonds between them. Okay, this is about PP overlapping. Next, another kind of covalent bond formation, that is pi bond. The covalent bond formed by these sideways overlapping or lateral overlapping of atomic orbitals is known as pi bond. See, in the earlier case in the sigma bond formation, atomic orbitals they overlapped on their axis of nuclei. In other way also covalent bond may be formed. In that, atomic orbitals overlap lateral to lateral overlapping. Means they overlap sideways to their axis of nuclei. If it is axis of their nuclei, they are overlapping sideways here and here. So thus the covalent bond formed is called pi bond. The covalent bond formed by the overlapping of atomic orbitals sideways or lateral is called pi bond. Pi bonds are formed by the sideways or lateral overlapping of p orbitals. Generally p orbitals they will form these pi bonds. The overlapping takes place at the side of two lobes, and hence the extent of overlapping is relatively smaller. In the earlier case, we have seen the sigma bond formation, overlapping is on their axis of nuclei, and the orbitals come into another to much extent. So their overlapping extent is maximum. Hence, we say sigma bonds are stronger. But whereas if you see in this pi bond formation, overlapping is just sideways. Okay, that's why the extent of overlap is not much to the not much to the extent. when compared to the sigma bond formation. That's why this pi bond is said to be a weaker bond than sigma bond. When compared to sigma bond, pi bond is a little weaker bond because the extent of overlapping is somewhat less when compared to sigma bond formation. So the molecular orbital is oriented above and below the plane containing nuclear axis. So here these orbitals will be oriented above and below the axis of their nuclei. So that's why only the extent of overlapping is somewhat less than compared to that in a sigma bond formation. Hence we say sigma bond is stronger than pi bond because in sigma bond formation extent of overlapping is maximum because these two orbitals will be on their axis of nuclei. When these two atoms approach each other, the overlapping occurs to maximum extent and hence the resultant bond, that is sigma bond, is stronger than the pi bond when compared. Okay, that is about pi bond formation. Okay, these are two kinds of covalent bonds. The covalent bond, which is formed on the axis of nuclei, end to end overlapping of atomic orbitals, results in the formation of sigma bond. Okay, if the overlapping of atomic orbitals is done sideways or lateral, that is perpendicular to the axis of nuclei, then that bond form, then covalent bond formed is called pi bond. Pi bond is weaker than sigma bond. And in the formation of sigma bonds, different types of orbitals they may participate in the overlapping. Based upon the types of overlapping, sigma bonds are classified into three types: SS sigma bond, SP sigma bond, PP sigma bond. Okay, but these pi bonds are formed by p orbitals only because they only can overlap sideways to their axis of nuclei. So S orbitals cannot. Okay, that's about S sigma bonds and pi bonds. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos. Please visit our website aimstoday.in for latest updates and recorded videos.